Hello. My name is Masao Murobushi. I'm from Connectech, Japan. Okay, first of all, let me introduce, basically today I'd like to introduce new package ideas and also next generation substrate. This is today's agenda. Company profile and printing bumping technology. Bumping technology is very unique because it's made by printing. Other people make solder bumping with other methods, but our printing is very, very simple, very, very inexpensive. In other words, very cheap, and also process is very simple. And also, I have some new idea for POP. Our POP is not exactly conventional POP, but we have a kind of a new idea to introduce to you. And also, we have also application to COC, chip on chip. Maybe you are not familiar with the terminology COC, but it means chip on chip, using our bumping technology. And also, in the last, I'd like to discuss about next generation of ceramic substrate. Now, maybe image of the ceramic substrate is kind of old-fashioned and also too expensive, but we have a proposal to make an inexpensive ceramic substrate with a very dense wiring density. First of all, our business activities. We are semiconductor packaging house, R&D, and also OSAT. OSAT means outsourced assembly and testing. Maybe something like AC, something like spill, but our scale is much, much smaller. We are Japanese assembly house. And also we also design and develop advanced package development. We call it advanced, maybe definition of advanced is very, very difficult, but we have very unique packaging idea. And with our experienced engineers, we have good technical engineers with a lot of experience and long experience. So if you have any problem in your production, maybe we can help you to solve the problem, like improving the yield, production yield, and some other improvement in your process. Our location. As I mentioned, we are, this is Japan. We have a headquarters in Niigata Prefecture, which is very close to Nagano city. And the reason why we chose this area is there are a lot of supporting industries around this area. And we have also sales office in Kyoto. Maybe Kyoto is maybe 1,000 years of the capital of Japan before Tokyo. So this is very nice city. Both cities are very nice. Maybe I can recommend you to come over and see us. And you can see, especially for cherry blossom seasons and snowing season. Maybe Niigata in the snowing season is not really good timing to visit because snow piles up like 3 meters high. So sometimes traffic is very, very difficult. But by the way, okay, go back to the subject. And we have an office in Taiwan, in Hsinchu, in Italy campus. Just opened in September last year, actually. Just not this year. Last year we opened in September. And we have also sales office in Korea, Seoul in Korea, also nice city in Korea. And we have Connectech China, This is also sales office in Suzhou. This is Italy campus photo over here. This is just a layout of the room. It's very simple room actually. Okay. So now this is our one of our key technologies. One is the bump on ceramic. But usually people make bumps on the wafer side, chip side. But our idea is we make a bump on the substrate side. And this is very important point by printing. The printing means this is very, very inexpensive and very handy and easy to make. And also, the other good point about this our bump is we call it damage-free bonding. Means this is a cross section, but our bump made out of silver-based bump. It's a kind of resin bump, and it means very, very soft. So damage when you bond it, damage onto the chips is very, very little. I mean, we can say that free from damage. And this is actually also doesn't melt. This material doesn't melt in the reflow. So even the temperature shock of the reflow process, it doesn't have that kind of problems. So sometimes the package has maybe for the testing stage, package performance is very, very good. But after a few cycle of reflow and also usage, sometimes package performance, I mean semiconductor performance sometimes goes down because of these reflow problems, also maybe some connection problem over here. But this soft bump is very, very stable in performance in that sense. Also, this is a process flow of a soft bump. We can print the bumps on the substrate in uniform way like this, very, very beautiful. And all we have to get from the customer is a bare wafer. With the bare wafer, we place the nickel gold plating. This is also, we do nickel gold plating over here. And back grinding. And came to our process. And this is substrate, incoming of the substrate. And we can print the bump. And we place the NCP dispensing. This is NCP means non-conductive paste, which means a silver paste or a resin paste, and flip chip. And this is the cross section. And this is the printing. Actually, we can apply to any kind of material. One example is film. The other one is on chip. And with this idea, we can create the new POP with the film and COC, chip on chip application on chip. I mean, without bumping system. Oops. So this is a bump on film. Bump is formed by printing, as I mentioned. No need wafer bumping. And so total thickness is about 300 micron. over here. And application can be a memory for POP. Maybe next page we can see the details. And touch panel controller, LCD controller, and FCP for camera, DVD, mobile. Actually, recent years and recent days, actually, this requirement of the POP is getting more and more. My colleague write down POP is increasing for smartphone, tablet, PC, etc. But always with the reflow process, this failure mode is a very serious issue. And the biggest cause of this problem is a warpage. This is warpage, disconnection problems. And also device is, the pitch of the device and pin count is getting more and more. So small pitch of the memory is required, and we can connection fail because more frequent and serious. And we will propose memory on field. Next page. When you actually you can see the actual sample in our booth in 1524 on this floor. But our idea is we use the ceramic substrate as a base, and we put the film substrate and fold the package like this. This is the combination. And the warpage issue, there is no warpage issue for this one because film is very free from warpage. I mean, connection never be disconnected with this connection. And advantage of this film device is also I/O. And since pitch is very little, like a 20 micron, so you can have a lot of I/O on the film substrate. This idea comes from an LCD driver, but we recommend to use this idea for memory device, and on the substrate side we can put ASIC, so we can have this new form of POP. And actually, some of the Taiwanese customers are very interested in this new package, and we are working together to develop this one. You can see it in the near future. And the other one is bump is also printed on chips, and again, no need for wafer bump, and even the shuttle wafer idea is available for this one. So you can, without a very difficult process like a TSV, you can pile up the chips, 2 chips together like this in the end with our soft bump idea. And possible application will be RF module, logic LSI, and CPU and memory stack. So this is also our idea for, as I mentioned earlier, we are very much supporting ceramic idea, ceramic substrate. And current ceramic, this is the most popular substrate, organic substrate for the BGA, PGA, everything. But line pitch maybe 50 micron, and package size 10 mm, and layer 6 layer like this. And the people's image of the ceramic